Dr. Sharat Kumar H, Head and Professor of Department of ISE, MIT, Mysore. And I am handling the subject called DBMS, Database Management System. It's one of the core subject in CSE and ISE. So it's a core, as I told, it's a core subject. Okay, and it's most required subject in our courses. It's the most required subject, and it's also one of the most real-time application used subject. It's the most real-time subject used subject. Okay, so DBMS is found everywhere. So wherever you go, you find DBMS. If I come to college, you can find DBMS. If I go for hospital, you can find DBMS, because everything is data storage. Everything is data storage. So if a patient visit to hospital, it's a data storage. If a student come to college, it's again the storage of a data. Storage of a data, right? Like that, DBMS is found everywhere. If you go to RTO to discuss about your driving license, again it's a database, it's a storage, it's a retrieval, right? It's a storage. Again, they will enter a DL number, you can find your information. If I go to college, you enter USN, you can find your details of by entering your USN student details can be found, right? If I go to hospital, if I go to Columbia Hospital, if I enter my patient ID, I can find entire information of a details of a patient who under the treatment of doctor, right? Like that. So DBMS is everywhere, every application. It talks about DBMS. It talks about DBMS. Such a wonderful subject. People are lucky to have this subject in your course. Lucky to have, because it's fantastic. It's fantastic programming it has. It is not like your C, C++, Java. It's a SQL programming. What it speaks, the way of speaking, it's a SQL programming that speaks about. Such a wonderful subject. Such a wonderful subject. Okay. So DBMS. One of the, as I told, it's one of the core subjects. First, I will go with a definition of dividing database management system into 4 parts. Okay, the first is data. The first one is data. So what is data? What is data? So data is information. Data is knowledge, right? So what is data? So data, if I write 75. I will write 75. What is this 75? Why I written 75? I like 75. I love 75. That's all. I don't know what it is. I just tell data. So it's 75. It's a data, right? So thing is, it's a 75, right? Data is something of interest. It does not contain any meaning. It's something of interest which does not contain any meaning in that. Simply written 75. Just be written 75. I do not know about 75. Just written this day. Like that, 75 is a data. It's a raw data. It's a raw data, right? So now I will tell 75 is a weight of Sharat. So I will tell 75 is a weight of Sharat. So raw data become process data. Raw data become process data. So data was thinking of something of interest be written, but later part I make it as a weight of what of Sharat. So weight of a Sharat is 75. It's become process data now, right? I may call it's a percentage. It's a percentage of Rahul. It's a percentage of Rahul, right? It's a percentage of Rahul. So Rahul has scored 75% in his B. Rahul has scored 75% in his B course. Right? Now it become process data. So it talked about raw data. It's gone, talks about the process data. So data is something of interest which does not contain any meaning. That is called raw data. Now I process this data through putting a weightage, putting and percentage. Now it become process data. Okay. So this is what data. So for example, I will give one small example, wonderful example. So now I am coming to what you call as, I want to come to MIT from Columbia Asia Hospital. Means near to the Columbia Asia Circle, what we call as. Okay. So from Columbia Asia Circle, I want to visit to hospital, visit to MIT. I'll just ask a particular person is standing behind any nearest to the auto or any auto person, auto driver, I will ask. So how to go to MIT college from Columbia Asia to MIT Mysore. They will tell, sir, go straight, go on straight, take left, then you find Kesari, then you go to MIT by just taking a diversion of road to straight way where you can find Nagulan to left and straight to MIT and take a right, you reach MIT. So what he told? He told about anything about data? Yes. He given information to me that this is the way to go to MIT. Right? He told how to go to MIT. Right? He told me go this way, take a right, and then go on. Right? It's telling, he told me, just told me like this, go like this. So he given information to me that I want to go to MIT, this is the way. What he has inside the mind, he has a knowledge. He has a knowledge, right? He has a knowledge as this is the direction to go like this. This is the direction to go like this to MIT, right? This is the way the person is just told me, go like this, take a left. He told me entire, he has a beautiful knowledge and given beautiful information, which is data is, that is MIT. That is MIT. That is MIT. So MIT has a data, information is that you coming, he has a knowledge that is given to me, information. That is the beauty of data with the information, with the knowledge. With the knowledge. Such a way that the information, data, knowledge just goes, right? Such a way the data, knowledge and information goes. Okay? That is data. That is data. That is and data. So if I talks about database, so still I want to talk about DBMS. So if I go to Aadhaar card, so why the DBMS comes? That's another question I'm asking, because DBMS, why need to DBMS? DBMS goes on, data structure comes, to data structure DBMS comes. DBMS 2, you want to go with file structure 2, then I want to go to, from file structure, I need to go on to some web applications. Web application 2, developing a beautiful design, a biggest software. Right? This is the way that goes. But why? Why the big data has been arising in the coming semester? You find big data. Why this data? Why this database are becoming big data, machine learning, and artificial intelligence? Why that required? Why has to be required? Because day by day you can find data is getting huge. Day by day, cannot imagine how much data has been generating. WhatsApp, you people are using social media. WhatsApp, it has a huge data, because so many people are, in Jio, people are using Jio 2 GB per day, 4 GB per day, Airtel has 2 GB per day, Vodafone has some there, 2 GB per day. So GB, providing a GB, so you're getting huge data, right? Huge data. Images you will download, videos, right? You download images, videos, blah, right? You download all the things. Later part, data is getting huge there. You people go to hospital, again data. If you go to somewhere, wherever visit, again everything data will be generated, right? Everything will be generated. So database getting huge. And if I talks about Aadhaar card, Aadhaar card is one of the huge biggest database that has, because getting a unique ID from Aadhaar card, you need to provide the fees, iris, palm, right? So huge data you want to providing 4 types of images to get unique ID. So main problem as a computer science or information science engineer, you want to think how the images you taken, how the unique ID generates, right? How it can be generated. It's a task, it's the biggest task, right? So taking a data, taking images, data, then unique ID. How it possible, right? So as a computer science, information science engineer, our job is to give solution for Aadhaar card to get a unique ID. That's what the people has done there. So that's what we want to, our job is to improve that accuracy of getting a results. exact results that has to be get. Okay, so getting it means another question arises: why you require that much of data to get a one unique ID? Right? Because of uniqueness, because of the property of uniqueness. You are searching the property of uniqueness in a biggest data, in a biggest population like India. Right? So very difficult task to produce an uniqueness property in a given biggest population. So getting a uniqueness, searching uniqueness, you require DBMS, because DBMS talks about most about uniqueness. Primary key, what we talks about. The primary key, what we talks about, which uniquely identify an entity in a database, or uniquely identify entity in a entity set. Okay, so I have a unique ID of SSN because social security number belongs to employee. If I talks about you peoples like students, you have a unique ID called USN, right? Unique ID called USN. So SSN, USN, if I go to anywhere, everybody has unique ID. Everybody has unique ID through your Aadhaar number. Through your Aadhaar number. So Aadhaar number is a unique ID. Bank, if you go to bank has account number, that is also unique ID. You have PAN number, that is also unique ID. See, we are searching, making duplication data and also searching for a uniqueness, because so much of uniqueness you need to require, right, to identify that is I am a citizen of India, that I am citizen of India. Basically on this uniqueness you require to find all the details. Okay, like that. So DBMS has such a vast of things has to cover, right? So DBMS, then I talks about file structure, it's about indexing again. So it comes with some web applications, some machine learning, then it comes with a big data with the Hadoop technology, right? So all this one you require to go on to build a wonderful system of without duplication, giving a fantastic unique ID for a particular person. So that is what DBMS, that is what an database. DBMS talks about the entire field of information science and computer science. Okay. So next one we talks about data. So then I will talk about database. DBMS. So database. Database. What is database? What is database? So database, it's a collection of related data items. 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 Okay. So if I tell it's a collection of related items, what is that? It's a collection of related database or related data items. So now, if I consider this college as a database, if I consider college as a database, so I told it's a collection of related data items, right? So college as a database, so it's a collection of related data items. I am calling college as a database. So it talks about employee as a entity of a college or a table of a college database. Table of a college database. So employees, because we are employees of a college, right? We are employees of a college with a teaching and a non-teaching faculty, right? So and then I have employee, then I have departments. We have departments. We have departments in college. We have departments. Yeah, departments. Right. So then we have college as a database with an employee and a departments as an entity set. Then I also have course student. Without student, college cannot run, right? We have a student. We have a student. We have a student. Okay. Then we have. So we have employees, we have departments, so then courses, then we have courses, right? So one database with the college name. If you tell database, it's a collection of related items. So myself, Sharath, this cannot be database. Sharath is itself a cannot database because I don't have any relation to be collected. Right? It's a unique ID. Every must whatever we speaks about the table, it must have independent existence. It must have some existence in the real world. So employee as SSN, department as a department number, student as CSN, course as course ID. For example, myself teaching in a DBMS is a course ID of 18 CS 53, right? 18 CS 53 TAS. So that is a Unicode. Right? So everybody has Unicode. Like that, when you write the database with the entities defined, it must have unique ID. It must have unique ID. Okay? It must have unique ID. So if I tell like this, so SSN name and D number. So SSN name and D number. So SSN is a key. We call it's uniquely identify the employee. So if I go to office and if I give my SSN or USN of student, it automatically details will be appear. But if I go to name, then duplication maybe arises. It arises maybe duplication. Right? So then department has D number, D name. Okay, D number, D name, and manager SSN. And a manager SSN. Okay, manager SSN. Then I have student as USN, name, faculty ID. So because each student has two requirement that each student has controlled by one faculty, mentored by one faculty. That is what I included faculty ID with the student. Okay, and it has course ID. Or a course ID or department number you may belong to, or you may tell that instead of course ID, tell that department ID that contains which department the particular student belong to. So belong to which department? Each student must belong to particular department in any college, right? Course as course ID, course name, semester handled by which faculty? Which course handled by which faculty, right? So now the question is, the database is a collection of related data items. So I'm talking here the collection of related data items. Let's tell this college is a database with employee, department, student, and the courses are related data items to the database college. So if I tell anything database, it's a collection of related data. So you cannot tell that something that college. You cannot put movie in this. You cannot put movie in this. Movie is a database of similar things. Not a similar. It's a other things, right? But college containing employees, departments, student, courses. These are related items to the database called college. It cannot be applicable for other things, like other database. But if I consider movie has different criteria, different things. It cannot be included here, right? So it's what? The collection of related data items. So if I go to bank, bank has branches, bank has employees, bank has accounts, bank has loans, right? So bank is different database, it has different collections. Like that, college is a different database with the different collections, right? This must be collected with a cluster of one groups. That is colleges, employee, department, student, and courses. So this is one collection, one set. So this is the only related items can be collected to one set. We cannot include other things as here. Means other things as means movie cannot be included. Hospital cannot be included in college database. There is different databases that contains. So it has names. So it is a related data items. So college with the employees, with the two departments, student, and a courses, right? So employee. So employees, unique ID of SSN, where myself employee is Sharath with the USN 11. So working for department information science engineering. So my department number is 4, right? So it tells that, so 1111, so name is Sharath, department number is 4. Department number is 4. Department number is 4. If I tell that, if I tell the department number, if I go for department number table, so civil as a 1, CS as a 2, so EC as 3, mechanical as, IS as 4, mechanical as 5. Mechanical as 5. So you can see department name, then comes with a manager SSN. So what is this manager SSN department table? I have told that departments, D number, department name, that's what department number, department name, manager SSN. Because I include manager, because each department has a head of the department in a particular department. Each department has a head of the department. That's what I include manager SSN, which is linked to SSN of a table of employee, which is linked to table of employee. Table of employee. Okay. Next I have student. Student as USN, name, faculty ID who is handling the particular, what is called faculty ID. Instead of faculty ID, we put SSN so that I can maintain the things of mentoring is easy, because I will include SSN in employee. There is no faculty ID. I made a faculty as employed. So that's what faculty is SSN. So I include faculty as a SSN. Instead of faculty, I put SSN as a unique ID for the employee. Okay. So student as USN unique ID. So name, so which is the student is controlled or mentored by which SSN, and the department is belong to. So particular students belong to which department. For example, USN of 4MH 18IS001. So 4 belongs to region, MH belongs to college. So 18 is the year, IS is the department where it belongs to, right? That's what. So USN, name, SSN and D number. SSN and D number. So which is belong to which department, controlled by which faculty, name, then there is a USN. There is a USN. Then there is other table called course. Other table called course. Course as course ID. So for example, course called maybe DBMS. I will speak about DBMS is a course. Course ID 18 CS53. Semester, 5th semester. Faculty ID or a SSN who is handling this subject. So myself SSN having 111. So handling subject called 18 CS53. So subject course name is DBMS. Semester is 5th. Semester is 5th. Okay. Semester is 5th. So this is the way the collection of database. This is a collection of a database of a what I call as college database. So many people are seen in almost 8 times I'm handling this DBMS subject. I've seen so many people, sir, telling that this is database. Sir, this is database. Sir, I create a database of my name. What is this? It is not a database. When you talk about database, you're required to talk about collection of related entities. Collection of related entities in that. When it talks about database, you make sure that you get at least 5 to 6 tables. That's the way database must be created. If I tell bank, and this is what I told bank has account, bank has customers, bank has account, employees, bank has loans, each thing, everything has unique IDs. Like that has been built. That is bank database have been built. Right? If I go for movie database, there is actors, there is actress, there is a movie IDs, there is musicians, there is a singers. Right? Musicians have control instruments. So database is huge. Database has been different. If I go to hospital has doctors, nurse, take care people, receptionist, patients, hospital itself ID. Right? There is a huge databases that contain. So if I tell about database, it must contain 4 to 5 entities in a particular database. That's what that time we can talk as a database. That time we talk as a database. So database is a collection of related data items. It's a collection of related data items. Collection of related data items. Okay. So now I will tell bank database. I will write it out. So it's easy to understand, because once I told college database, it better to write bank database again. So this makes different way of attraction towards DBMS. Towards DBMS. So if I tell as a bank as a database, so bank has branches. right? Bank has branches. So each branch has branch ID. Okay, so branch ID is a unique key. Then I have customers. Customer is customer ID. Customer has customer ID, customer name, right? Like that. Then I have employees. SSN. Employees, right? So employees. Yeah. Then I have accounts. Then I have accounts. Accounts with account number. Accounts has account number. So bank, branches, customers, employees, accounts. Then I talks about loan. Loan ID. Loan ID. Loan ID. So it has loan ID. It has loan ID, right? So branches, customers, employees, accounts, and loans. So bank has branches has unique ID, branch ID. So branches contains customers with the customer ID. So customers interacts with employees. Employees can be divided into managers, staffs of divide. You can divide into manager. There's a manager in every branches, right? Managers and section managers. We can divide into marketing managers. Various employees can be splitted, right? So that is employee. Accounts. So customer holds accounts. So employee maintains accounts. Loans. So branches provides loans. Loan has loan ID as a unique key. Loan ID is a unique key. So branches, customers, employees, accounts, and a loan. Hope you can easily understand now. So I built a relationship also, right? So bank has branches. Branches contains or have customers. So branches, employees works for branches, right? So accounts, customer holds accounts. So branches provides loans. See, if I tell a database, there is a relationship between every entity I speak. This relationship between entity I speaks with a unique IDs, with the unique ID of a primary key. Unique ID of a primary key. This is the way of collection of database, right? So if I tell a bank as a database, there is a collection of related items with the entities, with the attributes. Entities with the table name with the attributes. Table with the attributes, right? So bank has branches, customers, employees, accounts, loan with the IDs, with the attributes, with the primary key. What we speak about to uniquely identify entity in an entity set or identify table in a database, right? Table in a database. That's the called DBMS. That's called database. It's a collection of related data items with a fantastic example I hope I given. Okay, fantastic example I hope I given, right? Then what is DBMS? So talks about we talks about data, we talks about database, we now want to talk about management system. Talks about management system. You need to talk about management. What is management? So we have a database, you have a data, you built a database, you told collection of a database, then I need to talk about management now, right? What is management? How to management in DBMS, right? So here, so many employees, bank is, if I consider SBI, we have 1,000 employees working. We have 1,000 employees working, right? You want to manage entire thing. You want to manage entire thing of, some employees may quit in the between the things is, some employees may be quit, some employee may be recruited, some employees may get promotions, right? Some employee may get promotions, some employees may get depromoted, some employee may get update in a salary. You want to maintain entire payroll, right? Customers, if I talk about customers, so many customers quit, so many customers enters, they want to back balance, they will go to ATM, they will withdraw the amount. It must be updated, right? So means update the balance of customer in through account numbers. So there is a updation when you retrieve the money, withdraw the money, right? You may insert by putting your money to bank account, right? Then they may quit it. They decide to change the teacher decide to quit the bank itself. Then you want to delete. right? Then if I tell, that's what to manage, you want to manage entire account numbers linked with a customer account number, right? Then there may be branches, where is some branches they may work well, you want to delete entire branches, then you want to shift all the customers one branch to other branch, right? So all this is a manage. There is a insertion, there is a deletion, there is a updation, everything you are doing, right? So this insertion, deletion, updation, and you providing a security. Each customer has a unique secret code. That's called ATM pin. And unique for internet banking, again they have secret pins, right? So there is a security. There is a security to do this. It is DBMS. Entire thing is DBMS. Okay. So like this, we have an insertion, we have a deletion to do, you have updation to do, you have to provide security, right? Because without security, no database can be possible, right? So you need to provide security. You need to provide the security. So bank, when I talk about bank, this all must be happen. If I go for college, colleges employees, colleges students, colleges courses, colleges departments, right? So college, so again employees. Some may be equated, some may be assigned to assistant to associate, associate to professors, right? One cycle of way, 1, 2, 3, right? There is a updation, there is a insertion, there is a deletion. Again there is a students. So students will study for almost 4 years, from first semester to 8th semester. Some people may quit in the middle. Some students do completion of 4 years, then go off. So what to do with database? Because you want to maintain database, because they become alumni when they complete the 4 years of degree in particular college, right? So that's what the thing says as 1 to 4 years of data, active students, inactive students, again session, deletion, updation, so many updations, maybe address, phone numbers, fees updations, everything you want to maintain. So there is lot of insertion, lot of deletion, lot of updation, and providing security for a huge database, right? Everything is called management. Everything is called management. Okay, everything is called and management. It's a software. I would call DBMS, fantastic definition. So if I buy that one, it does not feel good. DBMS cannot be biated. One thing understood, DBMS, you cannot biat DBMS. Okay, DBMS is a way of feelings, way of understanding, way of analyzing. Such a subject is like that. You're not able to buy it and come back, this is DBMS, I will read it like this. Nothing. That is not possible in DBMS. DBMS is a way of understanding and way of expression. It's feelings to be expressed through databases. Okay? So it's a software, that's what I'm telling definition. See, I'm telling it's a software to process, to access and process a database. Hope it's correct, right? I'm accessing a database of a bank database and processing a database. Process means insertion, deletion, updation, and management. Right? So if I tell like this, it's a access. It's a software for access and processing a database. It's access and a processing a database. So simple definition, because it access, you want to access the database to manage, right? To access a database and to manage a database, nothing but a process a database. Processing can be written as insertion, insert, delete, update, insert, delete, update, and security. So it is the theme that it is accessing a database and processing a database. Processing means insertion, you're doing for the database, deletion, you're doing for database, updation, you're doing for database of n number of entities, with providing security to the database. Okay, it's a software. DBMS is a software to access and processing a database. Okay, processing a database. So DBMS. So I told data, I told DB database, I told DBMS. Right? So now we're able to understand what is DBMS. If I ask DBMS in the middle of midnight, you must tell it's a collection of related data items. It's software to access the database and process a database database, right? And possess a database. That is called DBMS. That is called a DBMS. Okay. The code of the subject is 18CS53. 18CS53. With DBMS we have 18CSL58. 18CSL58. That is which contains DBMS lab with a mini project. DBMS lab with a mini project. So it has like this. So 18CSL58 and 18CS53. So DBMS theory with a DBMS lab with a mini project. So whatever you studied. So see, DBMS I talks about completely backend. With front-end tool, like what you learn with the 5th semester Python. Python comes with DBMS as a front-end tool. You can store DBMS as a back-end and go Python with a front-end and develop wonderful mini project for any of the real-time application can be. Okay, consider Mahalakshmi Sweets. It's one of the famous sweet shop, right? Develop app for them using Python as a front-end and go as a back-end as a SQL. So customer comes, I need this one, just press the sweets, number of sweets available, just take it out. So how much you purchase, go on, next, automatically update the quantity, right? So everything is possible. So somebody want to book, instead of going, nowadays COVID-19, you cannot go to visit for hospital for this one, right? So sorry, Mahalakshmi Sweets for to buy the sweets. So required online shopping. Nowadays e-commerce is one of the famous thing, right? So that's what, you want to go for online shopping of a sweets. Just display the sweets, want to book it out, book. Get a delivery, pay online, get it out, right? So that's a very simple way of doing the mini projects for a simple Mahalakshmi Sweets, okay? Like that we have n number of shops, as you know. People want to come to computer to all this one. So make a small database, go give a shop, take any shops or take any real-time examples, go for doing a wonderful mini project for your what is called 18CSL58, which contains about 50 marks per project. I want to make a fantastic report and fantastic analysis and get a beautiful project to be done by yourself, by you peoples. You must students, you must engage such a wonderful project which can be done through many project. About pre-request, you want to learn DBMS. So first thing you want in mind you required a little bit knowledge of data structure, a small knowledge of software engineering and little bit knowledge of C. Little bit knowledge of C programming. So you required C programming, a C software engineering and C with SC engineering and data structure. That's enough to cope up with what you call as DBMS. So if you want to learn front-end tool, you're required to learn Python, .NET and a Java. Okay, so ASP.NET, Java and Python is a front-end tool. So Python itself you teach, Java you people learn with the OOC with the Java in the last semester, 4th semester. Okay, so it's what it makes comfortable, which if you go for Java to front-end and back-end as a DBMS, back-end as a DBMS, back-end as a DBMS. Okay, such a thing says there's a pre-request for this course. There's a pre-request that has to be put a consideration for this course. Okay, this course, the pre-request. So pre-request, DS, SC and C. If I go for front-end tools, then you require Java, Python and what is called ASP.NET. So Python you're learning yourself as a part of your syllabus with Python, and you can learn data structure only SC you people already learned. Okay. So next class I will discuss with the introduction we come up, then I come up with what are the objectives you want, why you want to learn this course. What are the outcome of this course? Right? So what is the objective? Why you want to learn? Right? What is provides? It provides. What the outcome you get it out, and how the syllabus look like. How the syllabus look like. Okay. Next class we will discuss about broad of this one. Okay. Thank you so much.